There are many instances both in like drawing, so using a lot of geometry, and then in physics where the slope is referring to the velocity, where we might want to find a line that is parallel to another line. And so the very first thing I tend to like to do is just to look at that line itself and get a good idea of what it looks like, because then it makes it a lot easier to identify a parallel line. So first we can identify the slope here and the y-intercept. Now we'll go ahead and graph those out, plot my y-intercept, and then our rise, or our change in y, is going to be -2, and our change in x is 3. So I'll go 3 to the right. And there's our second point. Now, a little trick is we can actually, since -2/3 is equal to 2 over -3, we can actually do it in the reverse order too. So go up 2 and then to the left 3. You'll notice that's all in the same line, and you can tell that it is, in fact, traveling in the downward direction. And the more accurate our graph is, the more likely it is that we'll be able to use it to verify our solution. Great. So now we have this line, and we're looking for a line that's parallel to it. Well, I'm going to actually toss that guide back up there. If you notice this line, if I just move it, well, that looks parallel still, right? So the idea, a parallel line is any line that does not intersect the other line. And you probably know, or hopefully remember, that they have the same slope. That's why they don't intersect. So for my parallel line, I actually already know one big piece of the puzzle. The slope is -2/3. Now I need to look back because there's a ton, in fact, an infinite number of lines that are parallel to, let's call it line L here. But they did give me one other piece of information. They told me that the line I'm looking for passes through this point here, -3, -1. So I'm going to hop over to -3, -1 and put a point there. And in fact, it would be very easy to graph this line now since I know the slope. I can go up 2 and then to the left 3. Or again, I can go down 2 and to the right 3, noticing those are both on the same line there. And in fact, because this line happens to it's very easy for me to find a point on the y-axis, the y-intercept, I actually already know what the equation of this line is going to be. But I do want to go through the algebraic process as well. Now, I will point out, if you know point slope form, we're just about done, because point slope form says that I can just take y minus y1, or the y coordinate of any point on the line, so y minus -1, and that will just equal the slope, -2/3, times x minus the corresponding x coordinate to the -1, which I know is just -3. And that's actually it. We could clean this up a little bit. And like I said, we're done. That being said, I know that a lot of my students are not that familiar with point slope form. They kind of rely on slope intercept form. So I'll show you how to do that as well. It's not that hard either. What we're going to do is just start with the generic equation here. We're going to fill in the values that we know. So we know the slope. We don't yet know the y-intercept. Again, I know that we did find it graphically up here, but let's assume that we don't know it. However, this x and this y stand for any xy pair on the line. So I can actually just plug in the -1 for y and the -3 for x, and then we're just left with b. So we can just solve for b, right? So I'll put this over 1 here. The 3 is going to cancel with the other 3. And so we get -2 times -1 is just 2. Go ahead and solve for b, and we get that b is equal to -3. Now that we know the y-intercept and the slope, we can use slope-intercept form. Y equals the slope, -2/3, times x plus the y-intercept, or in this case, just -3 or plus -3. And we have now found the equation of our line in slope-intercept form. Again, that does verify that our y-intercept here is at 0, -3. We already kind of graphed it out. And the last step would be to just actually graph it out and verify that it looks parallel. And again, your drawing is unlikely to be perfect, but you can see here, those look pretty darn parallel, and I will chalk up any mistakes there to my poor artistry. You'll notice that I've been using a subscript here. This is a notation that I like. And that's just saying the line, that this is line L, but the line parallel to it. And I'm not entirely sure how formal that is, but I think it makes a lot of sense. And it lines up with what I was using down here for the parallel slope as well.